Hi everyone, so today we're going to present about our IFL 3, which is about one sample test and two sample tests that the questions are generated from ChatPTF. And my name is Michelle.
My name is Amanda.
The hypothesis test plays a crucial role in business decision making because it helps them evaluate assumptions based on the statistical data instead of random guesses. And then it also helps them reduces error and validates strategies, and it's more likely to succeed when they want to launch a new product or change a new marketing strategy. So now let's get started to discuss about the questions that we prompted using ChatPTF. For the first question, it's a one sample test where the standard deviation is known. So in the case here, a manufacturer claims that the average lifespan of their light bulbs is 1,000 hours, and then the test is claimed we select a sample of 36 light bulbs, and the sample mean of the lifespan is 980 hours. The population standard deviation is known to be 120 hours, and the significance level is 0.05. So for the first step, we're going to state the hypothesis. So the null hypothesis is mean equals to 1,000, and the alternate hypothesis is mean not equals to 1,000 according to the case earlier. And from this, we get to know that it's a two-tailed. And then for the step 2, since according to the case earlier, we get to know that the significance level is 0.05. For the step 3, we're going to decide whether we're going to use the C-test or the T-test. And since in this case, the standard deviation is known, so we're going to use the C-test. And we're going to use this formula where x bar is equals to the sample mean, mu is equals to the population mean. This symbol is a symbol of the population standard deviation, and n is equals to the sample size. For the step 4, we're going to show the graphic about the critical value, where the critical value according to the C table is 1.65 or minus 1.65. So the null hypothesis is going to get rejected if the C value is less than minus 1.65 or more than 1.65. And then for the step 5, we're going to use the formula earlier, and then it's 980 minus 1000 divided by 120 divided by root 36, and then we get the solution, it's minus 1 for the C value. And so the conclusion is, since we get the C value is minus 1 and the critical value is minus 1.65, so the null hypothesis is failed to be rejected. Therefore, at the 0.05 significance level, we can conclude that there is not enough evidence to that the average lifespan of the light bulbs is less than 1,000 hours.
We also calculated in Python and the result turns out to be the same.
So for the second question, it's a one sample test where the population standard deviation is unknown. So in this case, a nutritionist claims that the average daily intake of fiber among adults is 25 grams. And to test this claim, they select a sample of 15 adults and measures their daily fiber intake. The sample yields the following fiber intake values. So this is the data that they collected, and then it says that the significance level is 0.05. And then for the first step, we're going to state the hypothesis, which is mean equals to 25, and then the alternate hypothesis is mean not equals to 25. And then for the step 2, like before, we're going to state the significance level that is stated in the case earlier, which is 0.05. And then for the step 3, we're going to decide whether we're going to use the T-test or the C-test. And since in this case the standard deviation is unknown, we're going to use the T-test. And so we're going to use this formula where the x score is the sample mean, the mu is the population mean, the s is the sample standard deviation mean and sample standard deviation instead of the population standard deviation, and then the n is the sample size. And then for the step 4, we're going to decide on the critical value according to the T table, which is 2.145 or minus 2.145. And then this is the graphic of the critical value. And then so the null hypothesis will be rejected if the value is less than minus 2.145 or more than 2.145. And then for the step 5, we're going to calculate the mean that we get using the data stated in the question, which is 25.13. And then we're going to calculate the standard deviation. And the first step is to subtract each of the data by the mean and powered by 2, and then we get all of these numbers, and then we're going to total it and then put it in the standard deviation formula, which is 144.409 divided by 15, which is the sample of the amount of sample of the data, and then subtract it by 1, and then we get the standard deviation is 3.21. And then we're going to calculate the t-value using the formula in this step 3, which is 25.13 minus 25 divided by 3.21 over by root 15, and then we get the value 0.157. And then the conclusion is, since we already get the calculated t-value and the critical t-value, we get to know that it's still in between the critical value, so we fail to reject the null hypothesis, and we can conclude that there is not enough evidence that the average daily intake of fiber among adults is different from 25 grams.
This is the calculation with Python for question 2, and the result turns out to be the same.
So the question 3, we're going to talk about the two sample tests where the population standard deviation is known and it is independent. So the question is, a researcher wants to compare the average test scores of two different teaching methods. Method A was used on a sample of 30 students, resulting in a mean score of 78 with a population standard deviation of 10. The next one is method B. Method B was used on another sample of 35 students, resulting in a mean score of 85 with a population standard deviation of 12. The question is, at the significance level of 0.05, is there a significant difference between the average test scores of the two teaching methods? Okay, so step 1, we're gonna discover the null hypothesis and the alternative hypothesis. So the null hypothesis is mu1 is equal to mu2. The alternative hypothesis is mu1 is not equal to mu2. Why we use equal and not equal is because of the keyword difference. And because it is equal and not equal, this is a two-tailed question. Now the step 2 is finding the significance level, and from the question itself we find out that the significance level is 0.05 from this part. Next, step 3 is deciding whether we need to use the z-test or the t-test. But because the population standard deviation is known, we use the z-test. Step 4 is finding the critical value of the solution or question itself. So after we know that it is two-tailed, we find the critical value, which is approximately 1.96. So we reject H0 if C is lesser than minus 1.96 or it is greater than 1.96. So this is the graphic itself. It is because we are using two-tailed. Next, step 5 is calculating the z that is from the question. So the formula for the z statistics is z equals to mean A minus mean B divided by the standard deviation of A divided by the sample of A plus the standard deviation of B per sample B. So after substituting the values into the formula, we find that the z is approximately minus 2.56. So the step 6, the final step, is concluding everything. So since the calculated z value is approximately minus 2.56, which is less than minus 1.96, which is around this part, so it hits the critical value, which is why we reject the null hypothesis.
This is the Python for question 3 and the result is also the same.
Okay, so the next is the question 4, where the two-sample test, the population standard deviation is unknown and it is independent. So the question is, a nutritionist wants to compare the average weight loss of two different diet plans. A sample of 25 participants using diet plan A and a mean weight loss of 5.2 kg. This is the sample standard deviation is 1.5 kg. A sample of 30 participants using diet plan B had a mean weight loss of 6.8 kg, with a sample standard deviation of 2.0 kg and significance level of 0.05. Is there a significant difference between the average weight loss of the two diet plans? So, step 1, we're gonna decide the null hypothesis and the alternative hypothesis. But because of the keyword difference here, we're gonna use equal or not equal to. So the null hypothesis, or the H0, is gonna be mu A is equal to mu B, and the alternative is mu A is not equal to mu B. So then step 2 is we're gonna find the significance level. But because from the question we can already find the significance level is 0.05. So the step 2 is finished. Step 3 is deciding if we're going to use the t-test or the z-test. And because the population standard deviation is unknown, we're going to use the t-test. Why it is unknown? Because from the question we find the sample standard deviation, not the population standard deviation. Okay, so next, step 4 is finding the critical value. So for a two-tailed test, why is it two-tailed? Because the equal and not equal to, and because the CF is 53, which is sample A plus sample B minus 2, we find that the critical value for the T critical is around 2.004 and minus 2.004. So we're gonna reject the null hypothesis as H0 and it is less than minus 2.004 or greater than 2.004. So we're not gonna reject it if it's around this part. Next, step 5 is just inputting all of the values from the question into the formula. And we're gonna find out that is around minus 3.39. And step 6 is we're gonna conclude that because the t value that we find is approximately minus 3.39, which is around this part, so because it is less than minus 2.004, we're gonna reject the null hypothesis.
This is the Python for question 4 and the result is also the same.
Next question, question 5, is where the two sample test is dependent of each other. A researcher wants to evaluate the effectiveness of a new studying technique on students' test scores. a sample of 10 students test scores was recorded before and after using the new study technique. At a significance level of 0.05, is there a significant difference in the test scores before and after using the new study technique? So, because from the keyword before and after, we find and conclude that this is a dependent question. Okay, so this is the scores before and after using the new study technique. And this is the students. Okay, next. First step. Same with the others. Step 1 is deciding the null and alternative hypothesis. So, for the null hypothesis, because again, the question they want to find the difference, we're going to use equal and not equal to. So, the null hypothesis is mu A or mu before is the same as mu after or mu B. The alternative is mu A is not equal to mu B. Okay, that's done. We're gonna go to step 2, which is finding the significance level. And again, from the question, we find that the significance level is 0.05. So that's done. Step 2 is done. Next, again, is step 3, deciding whether we're going to use the t-test or the z-test. And for the dependent, we're obviously going to use the t-test. So dependent is always using the t-test because this is a dependent paired segment. Okay. So step 4, we're going to find the critical value. And again, because this is equal and not equal to here and here, this is a two-tailed test. And with a df or degrees of freedom of 9, because n minus 1, which is 10 minus 1, we can find 9. So the critical t value can be found in a t table. Okay, and the critical value are approximately minus 2.262 or 2.262. So this is the graphic. So we're gonna reject the null hypothesis if it is less than minus 2.262 or greater than 2.262. Okay, step 5. This is a little bit different from the rest or from the previous solutions, because we need to calculate first the difference. You can use sheets or anything like that, and the difference is just the after minus the before. Okay, so this is the results. After that, you're gonna need to find the mean of difference first. So the mean is just by adding all of the difference and subtracting it out and dividing it by 10. That we're gonna find 57 divided by 10, which is 5.7. So the mean of difference is 5.7. So the next step after the finding the difference and the mean, we're gonna subtract the difference from each student by the mean. So 10 subtracted by 5.7, 4.3, and so on. After that, we're gonna finding the difference subtracted by the mean, we're gonna square it by itself. So 4.3 squared is 18.49, and so on. After that, why we need to do that is to find the standard deviation. So the standard deviation is using this formula, the root sum of this divided by n minus 1. So we're gonna just add all of this, and we find that it is 110.1. We're gonna subtract it by 9, finding 12.233, and we're gonna root it, and it's approximately 3.49. Okay, after finding the mean and the standard deviation, we can use the formula to find the t. The formula that we're going to find is with mean divided by the deviation divided by root m. After that, we're going to find that the t value is 5.17. So, since it's 5.17, which is greater than 2.262, so we're gonna reject the null hypothesis.
This is the Python for question 5, which also has the same result.
So this is our presentation. Thank you for watching.